Solve systems by substitution, the third tool in our solving systems toolbox. We've learned about graphing and we've learned about tables, which are especially good when we have situations like this, where we have y equals something, y equals some other equation, and we know that wherever they touch is going to be our solution. And that is really great, especially when you have y equals and y equals. Graphing calculators especially are designed to input graphs once you have y solved for. Unfortunately, that's not the form that all equations go. And today we're going to focus on what do you do when you have one equation that's solved for x or y like that. So say you have y is 3x plus 6. 6, it's a terrible 6, looks like a B, let's rewrite that 6. And then you have another one that's what's called standard form, where 2x plus 4y is like that. And you have to solve, again, the game is what x and y make both equations true. That's the game we're playing each time. For this, we need to use substitution, because here's the problem. This 2x plus 4y is 7 equation. We cannot solve that. It's a little distracting. Let's open it here. We cannot solve this equation because it has two variables. Same thing here. This also has two variables. But if I just had one variable, I mean, we've done a lot of problems like that this year. We do the old SADME, subtract, divide. We could solve this, but we cannot solve this until we get rid of one of the variables. So substitution is called substitution because you are directly substituting one variable in to another equation and replacing it with whatever it equals that the other variable is there for. So I've got a 2x over here, and if I replace this y with 3x plus 6, this would become an equation that had some x's, it had some numbers, and then I could solve for it. That's why this method exists. That's why we're going to learn it today. It does take quite a few steps, so if you don't already, have something to write with and something to write on. This and the elimination assignment on the next assignment are going to be the two that I really, really, really recommend you have a piece of paper and a pencil, because you're going to go step by step, and it's just so much easier like that. And if you try and do it in your head, you might go crazy. It's just too many steps. It's not going to work. All right, let's dive into it. Because these do take quite a number of steps, I've only given you a few of the full problems that you're going to have to write out. Instead, I've started with some nice, easy equations that's just getting you in the habit of trying to figure out which equation am I going to substitute in for the other equation, and how does that even work? So you have to ask yourself, same question I'm going to ask myself right now, does equation 1 or equation 2 have x or y on one side of the equal side by itself? Well, equation 2 has negative 7x and negative 7y both on the left side. It's not that. But equation 1 has this x that's alone on the left. Nothing is next to it. The y has 5 minus 9y there. It's really crowded in this hood of the y. But the x is all by itself. It's isolated on equation 1. That's all we're going to do for these first few problems. Number 2 for mine, and again, it might not match yours, so just figure it out the same way though, is now I have y by itself on the left side, so it's just y. All right, that's easy, right? 2 down, 6 to go. How about this one? It's been equation 1 every time, but not this time. Now x is by itself down there. That is equation 2 and x. And then we have equation 2 again and y. Easy, easy. And if you miss those, you can redo them. There you go. One last one. I've got equation 2 and y. So all I'm really having you do are 3 problems. And these 3 problems will be enough steps where it'll be like 10. It'll be like 10 problems that you're doing worth. Okay. So I'm going to write this one out So negative 6x plus y is negative 43, and y is 3x minus 19. And then I'm going to give ourselves a blank canvas here. Y is our isolated variable, and it is right here. So step one in substitution is I'm going to rewrite this top equation. I'm going to do that on this left side here. So negative 6x plus, so all I'm doing at this point is just copying this equation. Negative 6x plus, but when I get to the y, I'm going to substitute in everything that it is on the right side. And when I substitute every single time, I must use parentheses. Have to. And that's true really in math across the board. Anytime you substitute something in for something else, use parentheses. If not, you're going to make a ton of mistakes. And that is equal to, and again, I just follow the equation. So I've got my negative 6x plus, I wrote in what y is on the right side, equals negative 43. I complete the rest of my equation. All right, haven't given myself a ton of room, but that should be fine. The next step is I have to rewrite this and get rid of anything in front of the parentheses. Now, fortunately for me, on this problem, there's nothing in front of y. It's just plus y. But if this was plus 2y, I'd have to multiply all this by 2. If this was like minus 6y, I'd have to multiply this whole thing by negative 6 and do the distributive property for that. I'll probably do that with one of the next two, I imagine. But for this one, it's nice. I can just basically get rid of the parentheses and rewrite everything because there's nothing to multiply it by. So I'm going to put plus 3x, and then plus a minus is the same thing as a minus. So this just becomes negative 6x plus 3x minus 19 minus 19. Let's give ourselves more room for that too. Minus 19, that writes well, equals negative 43. Once I've done that, now this equation looks much simpler. I've got some like terms here. Negative 6x plus 3x. That simplifies to negative 3x. And then I've got the rest of my equation here. Minus 19 equals negative 43. Now I can do a little sad me. Add 19 to both sides. And I still have this negative 3x, which I'll keep in red. And that equals negative 43 plus 19. I can use my calculator for this, but I will do this in my head. Negative 24. And my final step, division. I've got this rabbit situation. Divide by negative 3. And I get x is negative 24 divided by negative 3 is 8. That is a ton of work. And I'm not going to lie, that's why you only have 3 problems to do. You're half done, but the second half's really much easier. Because we know that our answer is going to have to be in the ordered pair up here. Parentheses 8 comma something. What's our y, though? We have to solve for y. Well, y is 3x minus 19. So to get that, I can just plug in, since I know 8's x, remember I use parentheses every time I plug in, 3 times 8 minus 19, which is 24 minus 19, which means that y is 5. So I told you last 2 assignments that there's a reason why graphing and tables are going to be your best friend. The ability to graph any 2 equations and see where they cross is so much simpler than this situation that we have to do right here. It just is. And tests know that, which is why many times if you have to take them, they don't give you a graphing calculator and surely a Desmos calculator to be able to graph them. So this is very helpful to know how to do, but is also tedious. So we're going to do 2 more problems, and then we're going to be done. This one is 8, 5. All right. 1 down, 2 to go. Once you get a hang of this, it's kind of fun in the sense that like you get confidence of doing the same thing over and over again. All right, 2 problems left. I'll try and give myself more room this time. All right, I've got y is negative 14 minus 3x, and I've got 3x minus 3, y is negative 6, Once I write that out, I can get rid of the background. This is infinitely easier to see. I'm going to do what I did last time. I'm going to write my standard form equation first. But when I get to the y, since y is isolated again, I'm going to, in parentheses, remember, I'm going to write what y equals on the right side. Maybe I'll just leave that in red. So negative 14 minus 3x. And that is equal to, so I guess we'll still use this as a little equal to, negative 6. Okay, so first step, let's rewrite it and get rid of this parentheses. Now here's how to do this. I have some students like to call this the rainbow method. I don't know if you learned that way back. But notice how if I multiply this negative 3 to every term on the inside of parentheses, that includes the negative 14, that includes the negative 3. If I do that, it sort of looks like a rainbow. If I include, especially if I had like 8 terms in here and I made every one of these a different color, you'd get the whole Roy G. Biv experience. So for now, let's just do this individually. So the purple one, I've got negative 3 times negative 14. Again, you could use your calculator for that. That would end up being positive 42. And then the blue one, you do negative 3 times negative 3x, positive 9x. This eliminates my parentheses, which is great because now I can do my like terms. 3x plus 9x reduces to 12x plus 42 is negative 6. Then we go to our SADME. Subtract 42, subtract 42. 12x is negative 48. Divide by 12. X equals negative 4. So I know my answer, I'll write in the top right again, is going to be negative 4 comma something. What's that something? Let's figure it out. Y equals negative 14 minus 3 times negative 4. You could literally just type this part into Desmos, negative 14 minus 3 parentheses negative 4. It'll spit out the answer. And I recommend that because if not, you could make an easy mistake here forgetting that negative 3 and negative 4 make positive 12, and that reduces to negative 2. So I get negative 4, negative 2, and I'm just going to hope with everything in me that I am right. If you need that up again, just rewind this video. I could check this with a graph, but I'm just going to hope I'm right, and I'm right. Okay, last one, number 8. We've got x equals y minus 9, and 2x plus 4y is 18. We've done this 3 times now, so you might have seen the pattern. But let's go for it anyway. We're going to rewrite our standard form equation. But notice for the first time ever, since we've been doing these at least, x is the variable that's solved. I'm glad we get to practice this. So I'm going to replace the x with y minus 9. So parentheses y minus 9. Then I finish my equation down here. So plus 4y equals 18. And let's get our equals all the way down there. We're going to do distributive property first. Do 2 different colors of the rainbow here. Get rid of these parentheses. Okay, 2 times y is going to be 2y. It's taking me a little bit because I'm switching up colors here. The orange, 2 times negative 9 is negative 18. Plus 4y is 18. Let's simplify these like terms. 2y and 4y make 6y minus 18 equals, 18. Okay. SADME, add 6y remains. That equals 36. Divide. Another reason that I'm confident about this is that we're not getting any decimals. So unless I made a series of extremely lucky mistakes all at the same time, I'm probably right. And now I can plug in, which I'll do in the bottom corner again. So I know that x is y minus 9. Well, if y is 6, then it's 6 minus 9. And 6 minus 9 is negative 3. So I have negative 3 comma 6. Negative 3 comma 6. And because this is the last problem, I just want to make sure that I'm right. As a triumph for getting done with this assignment, which after you finish these 3 problems, after doing the first few that are easier, it will feel very good for you too. Negative 5, 4. Negative 5, 4. Well, I typed in everything correctly. Oh, except for the x here. Oh, show me negative 3, 6. Yes, okay. I was like, please, I really don't want to redo that whole problem. Okay. Whew. Oh, so glad that I got that right. Oh, thank you for going on this journey with me. It did take a few steps. That's why I only gave you 3 problems. Still, this video is over 16 minutes long, but it goes step by step over each of these problems, and you can refer back to these not only now, but anytime, like in 2 years, if you're like, man, I'm about to take the SAT. I forgot how to solve systems with substitution. Load up this video, watch it, review it, and be good to go. And remember, you can always check your work. You can check it with graphing, but you can also check by just plugging them in your individual equations and making sure that you're true that way. That is super high confidence that I love. Okay, I'm going to go now. It's almost a 17-minute video, but this has been a pleasure. Until next time, class away from class, I've been really enjoying these, and your teacher Dylan is so proud. Bye-bye.